Hello everyone. Today we'll talk about the solution to the problem sliding puzzle. Don't worry about the fact that this problem is classified as hard. This problem is not that difficult, and it's also pretty standard, because this problem essentially requires us to do an exhaustive search. An exhaustive search will typically be either a backtracking situation or some graph search situation. In this case, it'll be a BFS, because we want the least number of moves, and the BFS will guarantee that we find the node on the shortest path to that node from the starting position, because it looks layer by layer, it looks in the order of increasing distances. And of course we know that this will be an exhaustive search, so exponential solution, because we have a 2x3 board. Those are very small numbers, and even if we have something like 6 factorial times something moves, then it'll be okay on a board that small, so we can just look at all the moves. And now the only thing that is left for us to do is to actually code the BFS. So, first of all, in our sliding puzzle, in general, the moves can be either horizontal, which is, or in this case, I'm starting with vertical. So a vertical move will be moving from position I to position I plus 3. So that's simple. And now horizontal moves will move from I to I plus 1 for I in either 0, 1 or 3, 4. So those are all the possible moves. Later we'll be checking the fact that one of those positions has to be a 0. Now we want to maintain the states that we've seen, so we have to decide on how we are going to format the board position. We can either use a tuple or a string as an immutable representation. Probably the string is most natural. So we'll be having our target be 1, 2, 3, 4, 5, 0, and whenever we want to convert a list or tuple into a string, we just join with an empty string. We map str, so we convert everything to strings and we map it. So we first unpack the board, convert it into a string. If there's nothing to be done, then we can return 0. Otherwise, we create our queue. In Python, we have to use the double-ended queue, append the starting position, and our step is 0, of course. We'll be increasing it for every layer. Now, the way I write a BFS is, and it can also be done like this in, let's say, C++, we'll be maintaining and remembering the current size of the queue, and we'll be eating that many elements from the front of the queue for every increment of step. And now, before we make a move, we have our string representing the previous position, and for every move from I to j, we have to check if 0 is on one of those positions. So let's say that it will be on the first position of the move, on position I. If it's not, we continue. And of course, if it's on position j, we can just swap I and j. And this will not give us trouble, because I and j here in this for loop, because of how for loops work in Python, we can modify I and j freely. They will be modified to the next value in moves. Whatever we do here doesn't really matter. So we swap them together, and now on position I, we require there to be a 0. And now, after our move, so we want to modify the previous value, so we convert it to a list, something that's mutable. We swap position I and position j, convert it back to string, the same thing as we did before. If we've already seen that position, there's nothing to be done. If this is the target position, we have seen it for the first time, we return step. Otherwise, we add it to the set of seen moves and append it to the queue, so this is a standard BFS. And of course, at the end, our queue is empty, we haven't seen our final position, we return -1.